Good morning, my dear students. Today we are talking about lesson 1 in unit 1, curriculum prep. Good morning, my dear students. Today we are talking about mass and weight. This is lesson 1 in unit 1 for prime 6. First of all, what is the meaning of mass? Mass is the amount of matter in any object. Any object has mass because it consists of a material or a substance, some substance. So if we took, for example, wooden chair, and we said that this wooden chair has a mass of 50 kilogram. What is the meaning of this? This means that this wooden chair contains an amount of wood, its mass equal 50 kilogram. And this is another example. What does it mean? Your wooden chair mass equal 10 kilogram. As we say in this type of question, if he asked you what is meant by, to answer this question, you use the definition and put the numbers. As we say, it means that the amount of matter. What is the matter in the wooden chair? It is wood. Good. So it means that the amount of wood in this chair has a mass of 10 kilogram. The amount of wood in a chair doesn't change by changing its place. As it's an actual. As we said, for example, the wooden chair. If we calculate the mass of the wooden chair in our classroom, it equals 10 kilogram. What will happen if we take this wooden chair and put it on the moon? Does its mass change? No, it will not change because the amount of wood in the wooden chair doesn't change. So its mass doesn't change. What will happen if we took it from the moon to Mars or Jupiter? Also, in this case, its mass will not change because the amount of wood in the wooden chair doesn't change. So the mass doesn't change by changing the place, and this is a probability for mass. Another probability for mass, we will talk about 3 probabilities for mass. Number 1, all matter have mass. As we say, because all matter consists of some kind of substance or material. So this type of material or substance has mass. So all matter have mass, whatever their physical state. Solids have mass, liquids have mass, gases also have mass. Number 2, the mass of an object increases when the amount of matter in it increases and vice versa. For example, as we say, a wooden chair mass equal 10 kilogram because the amount of wood in this chair equal 10 kilogram. What would happen if we increase the amount of wood in this chair? Good, the mass will change and will increase. So by increasing the amount of matter in any object, its mass will increase because the mass is the amount of matter in the object. Number 3, the mass of any matter is a fixed value and it doesn't change by changing its place. As we took, for example, moving the wooden chair from Earth to Moon to Jupiter to Mars, its mass doesn't change because the amount of wood in this chair doesn't change. We talk about these examples. Now, how can we measure the mass? What is the measuring device we will use, and what is the measuring unit we'll use? Mass measuring unit, at first, we use 2 measuring units to calculate mass. Number 1, gram. Number 2, kilogram. When I use gram and when I use kilogram, we use gram for small masses, as we calculate the mass of this ring. This ring is made up of silver, but this ring is too small. It's light. So we can't say that the mass of this ring equal 1 kilogram. No, it's too much. But the mass of this ring equal about 5 gram because it's a light object. So gram is used to measuring small masses like jewelry or chemicals in lab. And 1 gram equals the mass of 1 paper clip. So if you bring a 1 paper clip and put it on a balance, sensitive balance, this will give you a mass of 1 gram. The measuring unit number 2, kilogram. Kilogram used to measure large object masses. And 1 kilogram equals the mass of 1 liter of distilled water. What is the meaning of distilled water? Pure water. Water doesn't contain any salts because the water we drink from the tap, contains some salts dissolved in it. So, what is the measuring device? And focus in this point. If he asked you in the exam, mass is measured in and mass is measured by. Mass is measured in followed by the measuring unit. Mass is measured in gram or kilogram. But if he asked you mass is measured by, so after by came the scales or the device used to measure this scale. So mass is measured by 2 arm scales or 1 arm scales. 2 arm scales like balanced scale, and 2 arm scales also may be sensitive scale as used by jewelers. When you're going to buy silver or gold rings or necklace, the man used a 2 balanced sensitive scale. So sensitive used with small masses, while balanced scale or common scale, also called common scale, is used with large masses as fruits and vegetables. While 1 arm scales also have 2 types. Digital scales give you numbers on a screen like the mobile, and 1 arm scale with a pointer, and your mother maybe use this type with a pointer in kitchen to calculate the mass of meat or vegetable or whatever. So 2 types of scales used to measure mass. 2 arm scales, 1 arm scales, and 2 arm scales have 2 types. Also 1 arm scale have 2 types. And this is the shape. This figure shows the shape of 2 arm scale, balanced scale or common scale, and this is 2 arm sensitive scale. And these are the 1 arm scales. This is the digital. As we see, there is a screen, and the numbers or the mass appear on the screen, and this is the pointer 1 arm scale used in kitchens. Note, mass measured by, as we say, came after by device, but mass measured in, after in came unit. Now we will talk about another scientific term called weight. But before talking about weight, we asked a question: why everything is flowing to upward go downward on Earth? If we throw in this pin upward, it will goes downward. Why? Think. Good. Due to the gravity, gravitational force. Earth has gravity, and the gravity pull everything towards itself, pull everything down. Anything goes up, gravitational force or Earth's gravitational force try to pull it down. But why objects in space don't fall down? We see in movies astronaut swim in space. Nothing pull him down because there is no gravitational force in space. So nothing pull him down. So weight is the force by which a body is attracted to the earth. Let's focus on this point because it's important. We said mass is the amount of matter in any object, and the mass doesn't change by changing its place. But weight is a relation between mass and gravitational force. Mass doesn't change, as we say, but gravitational force may be changing from a place to another. Maybe there is no gravitational force, as we say, in space. So, if there is a gravitational force, there is a weight. If there is no gravitational force, there is no weight. So, weight is the force. What is the force he's talking about? Gravitational force. It is the gravitational force by which a body is attracted to the earth. Good. Or it is the gravitational force, as we say, by which a body is attracted to the earth. The effect of weight is always directed to the center of the earth. Why? Because the gravitational force focused in the center of the earth. Anything moved downward because the gravitational force of earth that came originally from the center of earth. So how can we calculate weight? Weight is measured by a device called spring scale. And this is the shape of spring scale. It has a hook downward and another one upward. But weight is measured in, and we said after measured in came the measuring unit. So weight is measured in Newton. Newton is the measuring unit of weight. And what is Newton? Newton is the measuring unit of weight, as we say, and it is named by this name related to the man who discovered the gravitational force. And you know, it is name, yes, good, Isaac Newton. And we know that he was sitting under the apple tree and an apple falls on his head, and so he discovered that there is a gravitational force. So gravitational force measured in Newton. So Newton is a measuring unit of weight, which is almost equal to the weight of an object. Its mass equal 100 grams. The factors affecting weight. 3 things affect weight. What's the meaning affect weight? It means that these factors may cause that the weight increase or decrease. Number 1, the object mass. We said for a moment that weight is a relationship between mass and gravity. Good. The mass may be increased. So in this case, the weight will increase. Number 2, the place where the object exists. Why? Because when I change the place, the gravitational force changes. And by changing the gravitational force, the weight changes. Number 3, the distance between the object and the center of the planet, and this point we will talk about after a moment. Number 1, object mass. As we see in this table, this is examples for masses. Masses may be equal 1 kilogram or 2 kilogram, 3 or 4. So by changing the mass, we notice that weight also change. When the mass equal 1, weight equal 10. Mass equal 2, weight equal 20, and so on. And from where we get these numbers? From where we says that when mass equal 1, weight equal 10. From a law. To measure weight, we use a law. This law says that weight equal mass by kilogram multiply Earth's acceleration gravity. And Earth's acceleration gravity, he gives you this number of acceleration gravity in the problems, and almostly it equal 10. Maybe change from place to another. But in this case, or in this problem, we know that Earth's acceleration gravity equal 10. So from this law, weight equal mass by 10. When mass equal 1, 1 by 10 equal 10. When mass equal 2, 2 by 10 equal 20. When mass equal 3, 3 by 10 equal 30, and so on. So we notice from these examples that by changing the mass or by increasing the mass, the weight also increase. So by increasing mass, weight increase, and vice versa. What is the meaning of vice versa? It means that when mass decreases, the weight also decreases. It's called a direct relationship. Direct relationship means increase, increase, decrease, decrease. This is called a direct. A problem. So you focus with me to learn how to solve these types of problems. Problem number 1, the mass of a person is equal to 70 kilogram. Calculate its weight on Earth's surface. In these types of problem, you have to search for, to calculate weight. To calculate weight, you have to search for two things. Number 1, mass. Number 2, the gravitational force. We have mass equal 70 kilogram, but there is no mention for gravitational force. In this case, we will use gravitational force equal 10. If he didn't mention the gravitational force in the problem, you will use it as 10. So to solve this problem, we will search for mass and gravitational force. We have mass here, 70. We have mass here, 70 kilogram, but there is no mention for gravitational force, and we said that gravitational force in this case equal 10. So weight equal mass by 10. 10 related to gravitational force. Mass equal 70 by 10 equal 700 Newton. And don't forget Newton, because Newton is the measuring unit of weight. Problem number 2. If you know that an object weight on Earth equals 300 Newton, calculate the object mass. How we will calculate the mass in this problem? We said that weight equal mass by 10. So mass equal, from the law, equal what? Weight divide 10. And we said that if he doesn't mention the gravitational force, we will use it as 10. So mass equal weight over 10. Weight equal 300 over 10 equal 30. 30 what? The mass measured in kilogram. Good. This is enough today, and we will complete another session. Thanks for listening, and see you later.